Hey everybody, Workgroup Devices meeting for August 20th. I will share the agenda. Let's see. All right. Well, welcome back, Patrick, from your time off. Looks like you've got the first agenda item here, so why don't we just jump right in?
Yeah, I'm not sure whether we want to discuss it in this order. I just basically added something that came to my mind that I want to discuss at some point. So the first one is a technical implementation. It falls under the promote the current structured parameters to beta aspect in a sense, because it touches the implementation of those. The current situation is that structured parameters, a resource claim gets a finalizer before it's marked as allocated in the status. And that ensures that a pod, when it gets scheduled, actually has a chance to run on the node that it gets scheduled to, because the claim is guaranteed to be available with all the information that is needed about the allocation. And I started wondering, this finalizer update needs to be done separately from setting the status. So there is one additional API server call whenever some claim gets allocated. And I was wondering, well, we could avoid that overhead. This then leads to that failure scenario that I outlined here. A user could accidentally or intentionally delete the claim before the pod actually, or already before the pod starts on the node. And the effect is that when kubelet tries to start containers, it can't find the claim. And that's basically a permanent failure condition. The user could try to recreate the claim, but it will not help because the scheduler will not redo the allocation. It's basically a permanent failure at that point, which is kind of bad. It's worse than it is with other similar cases. Say, for example, when a pod references a secret and that secret isn't available, the user can fix it by creating the secret after the pod has been scheduled, but not in this case here. So I wanted to bring up this topic for discussion and thoughts, whether we should keep the current behavior despite the overhead, whether we should simplify it with that known failure scenario, or do another third alternative, and that is extend the API server to prevent deletion of a claim when it's allocated. And this has a precedence, I think, with pod grace period handling. But I would need to discuss it with API server teams and API reviewers, whether that actually flies. So I see some hands. Go ahead. Antonio, I think you were first.
Yeah, and when is the finalizer added?
It's added by the kube scheduler before it sets the allocation status. So it will not proceed with pod scheduling unless the finalizer is in place and the pod status has been updated.
So the finalizer is actually avoiding this problem, right?
The finalizer avoids this failure scenario, but
Okay.
it comes with a cost of one additional API server call, because updating a status cannot at the same time also set a finalizer. It's two different resources. That's
Yeah, it's metadata. You can. Other thing is that we, since I don't know which version, with status only update the status, but is it possible to do both things? But is that a
yeah,
big?
it's not allowed. It was actually implemented like that before, and it was called out as a
Okay.
bug in the type implementation, and I fixed it, I think, in 130.
I know
So,
Jordan is chasing everyone with that.
yeah.
Sorry, last question. The thing is, why is the concern of these two API calls? We do that in a lot of places. Is this something that we are trying to optimize
It's an
because we know it's a
optimization.
problem?
Yeah.
Okay, so but
Yeah.
okay,
Yeah.
but we can live with that. Okay, thanks.
I think this is a good discussion because we are kind of solving the similar thing. Because of the lack of the DRA support for now, we are going with the device plugin support. And I think it also has a similar concept of that if you're failed to associate a device or allocate a device, your pod goes in a failed that goes in a failed state forever. So there is no kind of a retry. I think it's a similar behavior in the in this as well. Is that correct, Patrick?
Yeah, the kubelet will retry, but there's no automatic support for actually fixing the problem. So the pod will basically just be in a permanent state where kubelet retries every minute or so, and it will not go out of that state until the user deletes the pod and starts anew.
So then what is kubelet retrying for?
It's looking again for the claim, hopefully with an allocation set, but because the kube scheduler is already done with the pod, it will not allocate the claim again.
Got it.
So
Is it the same
P-
case for the device plugin as well? Like device plugin, once you get an allocate call where that means scheduler has already scheduled the pod on that node where the device exists. But let's say device plugin fails to allocate for some reason because it doesn't have any goal state. Kubelet does not retry at that point, right? And at that time, at least what I've gotten from Kubernetes document for the device plugin.
I'm not sure
They
about.
will,
Yeah.
they will retry, or depending on what the error is, it'll give you a, I forget what the actual error is. It'll give you an error, and then you'll be permanently failed without it having the chance to try and reschedule. So it either permanently fails, depending on what error code you get back from the plugin, or it keeps retrying forever, same as this.
Interesting. Okay, so there is a retry thing which I think I'm missing. So I'll check it out. Thanks, Kevin. Thanks, Patrick.
Yeah, and for device plugin, it's only like it's scoped with kubelet only, and in case of DRA, it's absence of a object in API server side. So like the link between two objects is broken on the API server side.
Right, we would have to have the scheduler reallocate, even though the pod, it doesn't get the pod. So it's kind of a artifact of separating the two things into two separate resources and not having transactions or integrity constraints. So I think, Patrick, in my opinion, this would be something we would not optimize right now. If we find that we're seeing the throughput on scheduling is too low and that this would make a significant difference at some point, then we can investigate whether there's a need to optimize this in some way. That's my opinion.
There have been proposals in the past to allow the kubelet to bounce pods back to the scheduler in some way. Right now, we don't allow that. Once the scheduler schedules on a node, it's done. That pod can never be rescheduled again. But we've talked about ways to allow the scheduler to say, or the kubelet to say, hey, scheduler, this pod failed. Try and reschedule it or create a identical pod, something. We never really came to a conclusion on what the mechanism would be. But in theory, that might help alleviate this as well as other problems we've had with the device plugin in the past.
Well,
Sorry,
either way, I'm fine with not optimizing it right now. My only concern is that it might be an API change. If we change to this special code in the API server later, if we don't do it now, it might need a cap and a feature gate and all of that. So I at least wanted to ask whether it's worthwhile now, but I'm fine with not optimizing it right now. I also do have a task somewhere about doing performance testing of structured parameters using the scheduler perf tests. I may look into that again, see whether it actually shows up as a significant part of the work or is completely irrelevant.
So one thing, it's okay to not optimize at the scheduler thing for scheduler to not reschedule the pod, but once it is on that node, the behavior of kubelet retrying mechanism with the DRA or with the device plugin, that behavior will be same, right? The return codes, is that behavior?
Nothing's changing there, and I think what Patrick has in there now prevents the failure that he's listed here. What he was saying is if he does this optimization, he gets the failure, but nothing's changing about how device plugin works, and the retries that Kevin described still exist.
Okay.
The question, what Kevin added is that there's a cap out there in Signode to bounce back a pod to scheduler and put it back through the scheduling loop. And as far as I know, that has not advanced yet there, but there was discussion of it. I don't even know if there's a cap yet, but there was discussion of it.
There's no
6
cap
months.
yet.
Okay. We have a couple hands. I don't know the ordering, but Abhishek.
Yeah, thanks. So, I mean, as I understand, and this is not a DRA problem like the kubelet retrying. It's something, a code Kubernetes problem, and please correct me if I'm mistaken. The question really is there a way to communicate a device status in our current scheme such that the scheduler picks up a healthy device?
So today, unhealthy devices stop being published by the driver. We don't publish an unhealthy status. Also, we don't publish a status for, well, is that, I don't believe we implemented publishing a status for the actuation of the claim. So outside of the pod status, is that right? Patrick, as I recall,
That's
pushed
correct.
that.
Yes.
Yeah,
Yes. We
okay.
basically don't have a claim. We don't have a claim status beyond allocated. That's
Oh,
what we have, and we don't have anything about health of the claim or health of devices in a resource slice. That is all future work.
That's right here. So what I'd like to do, does that answer your question, Abhishek?
yeah. Thank you.
Marlo.
Kind of the same thread. I was coming here mostly to talk about scheduling also. A scheduler that's not the Kubernetes scheduler. So we still have the same problems. And I was talking to Kevin a little bit around the getting stuck problem, right?
Yeah, well, there's that, but there's also at the moment, we don't really support any out of tree schedulers because there's no way to have 2 schedulers running simultaneously in the same cluster right now because there's no common place, as they mentioned, where we're writing the status or tracking what devices are being allocated such that 2 schedulers could compete for them at the same time.
Well, you'd have to separate the nodes.
Yes.
Like if schedulers must own a node completely, not a cluster.
Per node, yeah, that's right.
Okay.
So if I want to write a custom scheduler, I can't right now is the summary.
No, you can. The issue is and this issue exists in Kubernetes regardless of DRA, the 2 schedulers operating on the same node can run into race conditions.
You'd have to make sure each scheduler only operated on resource slices from different nodes.
From a set of nodes and that the other scheduler is not conflicting, right?
Correct. There's no coordination between 2 schedulers on individual nodes. So because we don't have a status that we write, that basically, right, you could over allocate.
Gotcha.
And you could also over allocate for all of the other resources. So this is not not specific to DRA.
Yeah. Got it. So I can still write a scheduler as long as it owns that and I'm not conflicting with the current one. Gotcha.
So Marlo, we have 2 choices here. One, we can, was that it? That was all your questions? Okay. I was gonna say, because this, you have one more item, Patrick, but this, as you can see, is a long list of things. And I was thinking we either time box it or we make it go last. But what I wanted to do, well, go ahead, Patrick, and then I'll go into my item, I guess.
Yeah,
I just want
with my item, I just wanted to point out that there is a GitHub project where I'm tracking issues related to DRA, issues and pending PRs. That's this project link here. And as far as I'm concerned, I'm trying to keep that project up to date so that anything that is being planned for, say, the upcoming release in 132 should be on that board. If it isn't on that board, I'm not going to look at it. I think it's a bit more fine-grained than just one item per cap. Like the CAP issues are of course also a way to track work, but I found that it's typically too coarse. You need more. You need to split up the work on a CAP into individual things that different people can work on, and I'm trying to do that with that project. So for once we are done with a discussion of what we want to do in 132, I would like to see that board being used a bit more to actually track the work that's ongoing and who's doing what and so on. That was just my point here.
No, that's awesome. So what I'll do is after this discussion, probably not today, but probably next week. But I'll take all of these bullet points and create, assuming we are all sort of more or less in agreement that we might want these someday. And then we can organize them and prioritize them using that. I'll create issues for each one.
Yeah. And you might notice that I turned some of your bullet points into links already, because there are some
Awesome.
issues already for the autoscale implementation, for example. I created one issue for the cell cost limits today because it was brought up on Slack, and Jordan basically confirmed what I suspected, that this is something that we need to do in 132 before promotion to beta. So,
okay, yeah. Awesome. So what I wanted to do in this big long list of bullets was, all of these bullets mean things to a couple of us, a few of us, but probably not to everybody in the community. So I wanted to go down through each one and try to talk about what they mean, and if people have questions about them, answer any questions. So if people think that's a useful way to spend our time, that's what I wanted to do next. So on the debate, taking things to beta, I think that's pretty clear that we want to do it. I think this other one, taking to beta, we discussed it a little bit in a previous meeting, and there was a comment that I think it might not be able to go to beta in 132. I guess there's no DRA integration with it. I thought there was going to be, but maybe there's not. So what is that? So in 131, Sergey implemented looking at resource health, device health, and reporting that in the pod status. So this gets a bit what Abhishek was talking about, being able to see in pod status something about the device health. So there's an additional, I believe there's an additional gRPC call to the device plugin. I'm not sure if that's true, that allows this information to be propagated.
No,
So
information was already there.
Okay. Okay. Information about it. So now this is exposed in pod status. And Sergey, so it's only device plugin support right now. There's no DRA support for it.
Yeah, only device plugin.
Okay. So then probably we have another one. Did you want to take that to beta, you think, in the next release for device plugins at least, or for add DRA to it and keep it in alpha? What did you want to do for that?
Yeah, I wanted DRA and I'll keep an alpha, but I'm not sure how much progress I can make on DRA. So I don't know.
Okay, so the point of going through all these is so that, and it doesn't have to be live in the meeting, but so that the folks on the call and listening to the recording can come in and weigh in later and say what's important to them. So that's the ask here, right? Like, I want to explain what they are, but I want to get feedback on what's important. I know it's important to me, but I don't know what's important to everybody else. So just to note that. So I think adding DRA support this would be important. So I might, figure out a way to make that happen.
How do you want us to give you that information, like +1s to particular items in the spreadsheet? Something else?
Very good question. I guess if we move these to issues, then probably the comments there, but there's so many of them, it might be hard to track. So we might want to end up with a some sort of summarization of them. What I was sort of thinking in that comment I just made was just people would just come into the document and +1 it, but which would be a fine way to start. But if we move them to issues, then you can +1 the issue or thumbs up the issue or something. Okay. Okay, the next one on the list, partitionable devices. So what this is, did you want to talk, Kevin? I see you unmuted, if you want to explain.
I assumed I would at some point during this, but you can,
Okay.
you can start.
So what this is it's the ability to support dynamically partitionable devices like MIGs in a dynamic manner. So also for TPUs, we can use it. So it's only on the resource model side, and it allows the device vendor to specify the valid partitions of a physical device.
Potentially overlapping. Yeah, potentially
Yes.
overlapping devices, and the scheduler needs to be able to treat it in such a way that if you allocate this device that overlaps this other one, it takes that one out of the ability from being scheduled. And we actually worked through a number of different designs for this in the previous release, but we could just never come to an agreement on the right way to represent it. And so we decided to push it to the next release. So I already plan on writing a KEP for this and starting the process on getting this ready for 132. So this will actually be one of my main focuses.
Is it going to be the same thing we merged in the KEP for 131, or do we expect another design?
It will be different than that. That was the controversy, was that what we presented wasn't what we actually agreed on in the end. And so we decided not to do it for 131. And we have a new proposal, which overall I think is better. So yeah.
Yeah, Mrinal, you I think raised an issue specifically on scale.
Yeah.
In that kind of not derailed, but that made better our proposals. We ended up putting together 4 or 5 or 6 different options and estimating the kinds of scalability issues you were concerned about. So we haven't concluded on that, but this, as Kevin said, this is one of his top priorities, is one of my top priorities as well.
Okay. Yeah, absolutely. Yeah, definitely interested in this one. So happy to participate.
Okay.
Awesome. This one I added just the other day. So there's an intention for this other KEP for in-place update of pod resources to go beta in 132. Right now, in-place update of pod resources means memory and CPU, I believe, is all that's supported. So, however, I think it would be potentially useful to be able to support in-place update of device assignments. Actually, this would solve your problem you brought up earlier, Patrick, because if they deleted an allocated claim, you could kind of reinitiate the allocation process through an update, in-place update. So I was curious, we hadn't really talked about this in the past, and I was curious if other people had saw similar value in this, but anyway.
How does it work for CPU and memory? Does someone just edit the pod object and change the limits and requests for CPUs and memory, and then magic happens and they get more, or what's the user facing?
I haven't dug closely into the details. I don't know if Tim Auclair is he's probably not here. I don't think he comes to this meeting. Or Sergey, if Sergey is aware. I haven't dug into the details, but basically that's my understanding of it. Yeah. So you can increase them. Mrinal might know more about
Yeah, I just pasted a link, Kevin, that goes over the current stat. But we're trying to move that to beta, and hopefully we'll get there in 132.
I'm sure. I think what the equivalent in DRA would it be we can change what claim is bound to the pod?
You could actually detach and attach GPUs is the thinking I had. So you could, now obviously it's a new driver call, right? It's a new driver call, but basically when the pod shuts down, we release these things. When the pod starts up, we add them. So an update is essentially the same thing. We release the devices that we no longer need according to the update, and we add the devices that we want to the containers. Obviously, workloads might be disrupted by this. Workloads might need to restart, as opposed to where you just give more memory to a container. The workload's not interrupted. So there's possible caveats to it, but I think it could be an interesting piece of functionality.
Yeah, we may
It
need
doesn't
some.
feel like a 132 thing to me, but yeah, I see there being usefulness in it, but not right
Maybe I
away.
don't, not a 132 thing, but I mean, there's so many things on this list. Many of them aren't going to be 132 things.
Yeah, I think this may also need some details on how it will work at the container level. Like, do we need a standard hook or a hub or a signal that a container can use to go, oh, okay, I got the signal, I have to refresh my devices or reevaluate the resources I was assigned at startup.
Yeah,
I
absolutely.
also don't know how to dynamically inject the device node into a running container.
Yeah,
Not really
It's
supported.
actually a bigger problem. So none of the CRI and like the runtime and the low-level runtime is able to do the things of dynamically changing the devices. It's like one shot only when a container is created.
Such it may be possible on the VM side, but yes, on the container side, I don't know off the top. That's something we can.
It's exactly the same problem. So practically, like, you need to modify the C group to grant the device access, and you need to create like MK nodes, and none of them is supported in any of the OCI runtimes. So only on creation time right now.
But that's probably true of CPU and memory too, other than the implementation of
CPU for CPU and memory we have update calls. So those can
right.
be
So
changed.
there'd be a lot of work to do to make this happen, so that we have to understand whether it's something.
Yeah, I think if this is a priority, maybe we can open some issues on the low level runtime side and investigate if it's going to be feasible. Like maybe a run C issue. I can create one and then we can take it.
Okay. Okay.
Yeah.
Okay.
Yeah, I mean, I just had a quick comment on the in-place device support for partitionable devices. I mean, this is challenging because unless the placement and alignment is correct, it will create a lot of fragmentation on that node. And that will lead to poor accelerator utilization, or even density-wise packing more pods on the same GPU. So this clearly needs a thought around how we can reduce fragmentation when we do such in-place updates.
You're talking about the combination of in-place updates and partitionable devices may yield more fragmentation.
Yeah, will definitely yield more fragmentation for sure.
All right. Interesting concerns.
Yeah,
Okay.
I think what may be interesting is this regards is ability to remount to different devices or reconnect to different devices. If these devices are failed, we will have a way to get the same number of devices on the same node, but healthy. But I don't know how much it's the same cap or different.
Yeah, that's a good question. That's a good point. It potentially, I mean, that could be just an invisible process, so it doesn't actually require in-place updates, right? If we detect a failure, we could remount. We'd still need some of those mechanisms though, so but you don't need an API for that.
Yeah, perhaps.
You see what I'm saying? Yeah. Okay. Anyone else feel free to add comments if I missed somebody's comments on here to any of these, obviously. Next item, these are in no particular order, by the way. Next item here, resource claim status with possible standardized network interface data. So this is an opaque driver-owned status field on the resource, really on the so we could put this directly on the resource claim status, but of course, if there's multiple devices allocated in a single claim, then we might need a status per device. So we either need some structure that captures it that way, or we already have the allocations. So maybe it's like a sibling to the allocations. We'll have to work out the specific API. Name status to provide per device status and data. So network drivers have some common attributes, probably want some standardization there. So here it's like if you allocate an IP address for a device that you've created through DRA, you want to write it to this place so that other controllers can access that, and regardless of which device vendor driver allocated it, it shows up in the same place in the same way. That's what I mean by standardization there. Right now, this is workaround is to use a CR. So you'd have to create a separate CR to store that IP address or whatever it may be. This is separate, Abhishek, from. Did somebody have a question?
I was just gonna qualify that with an out of tree CR, so something custom.
This is different, Abhishek, than I lost my place here. This is different than the health of the device. This is about the status of the actuation of an allocation of a device within a pod. So we can attach configuration to a claim and say the configuration, the driver is unable to apply the configuration to that device. This is where that failure would show up. That's an example of the kind of thing that might show up there. So the positive things that might show up are metadata attributes like IP address or data like IP addresses, and the failure statuses that might show up are things that are specific to being able to actuate this claim for this pod. Yeah, Lionel.
I will.
Sorry. Just understood. Is what we are saying here about to land in 1.32, or it's for even beyond 1.32? I mean, for example, this feature.
Can you ask that again? I didn't quite follow.
Is this feature will be released as part of 1.32?
But that's what we're trying to prioritize, right? So this discussion is, here's 10 or 12 things that we as a community have talked about, additional functionality we want for DRA. I'm trying to go through each one so that the community has some idea of what it is we're talking about here, because a one-liner might not be enough. And then we need to work together to prioritize what's going to get delivered. So if this is something that's important to you, then yes, please let us know and join in and participate in making it happen is even better. The best way to make sure it happens.
Okay, understood. Thanks.
Yeah, sure.
Yeah. So I had a question, like going back to this config failure report. Then what is the behavior of the kubelet? Like, does the kubelet still keep on retrying, or this is before the kubelet actually retries?
So what would we do today, Patrick, if we had a failure at this point? I think the pod would get marked as failed. This gets back to the earlier discussion. I don't know what conditions under which we keep retrying versus.
We always keep retrying.
Okay.
The node prepare resources call fails. For whatever reason, it will get retried. There is an open issue. I think it's the one that I linked to earlier about having permanent failures reported there versus temporary errors, but that's not implemented right now. It's all assumed to be temporary, and Kubernetes will retry.
Okay. One thing that, at least it's interesting from IBM side is, how long does this take to glue all this stuff together, right? The reason I say is that cloud providers offering inference services, have some SLAs tied to, booting up the next inference server, so that, the inference request can be satisfied by multiple users or single user. So maybe it's good that at some point post 131 we stop and say, look, this is the end-to-end latency for gluing the entire thing in an happy path scenario and in a sad path scenario. That would be great.
It would be, I think, I'll say yes. I agree. We have those concerns, at Google about being able to provide lower latency satisfaction of these things. If it's a retry, that just gets to Patrick's point. Probably we need to be able to. I'm glad you put it in link it right directly in the agenda too, Patrick. The permanent failures, right? We should be able to resolve that unhappy path pretty quickly. Permanent failures, we need to decide whether it's an infinite retry or what we do. Like, if there's features for that. So if that's something that's of interest to you, probably you should add it to this list or create an issue so we don't lose track of it. That would be helpful.
Yeah, so I'm going to add it to this list. Yeah, thank you.
Awesome, thank you. All right, next item, DRA usability enhancement. So this is very ill-defined right now. If you look at the usability of device plugin, where you just say nvidia.com/GPU2, and you look at doing the equivalent in DRA, it's a lot more work. Okay? There's a lot more resources. It's got a lot more expressiveness. It's got a lot more flexibility. It's got a lot more functionality, but that comes at a cost of more work. So the question here is, can we improve the usability? And we've bandied about a few ideas, even if in the common cases, especially, right, where we like one thing we've talked about is, like, instead of nvidia.com/GPU, you could put in device class foo, right? I want to, right? And now all of a sudden that's a bunch of boilerplate that you don't have to write from that one line. And that can be implemented directly. It could be implemented with a webhook. Like, there's lots of different options, but those are the kind of ideas we want to discuss in the usability enhancement. To me, yeah, so that's what that is. Patrick.
Yeah, I just added one issue link for something where we have captured some of those ideas. It's around cell validation, cell errors that can occur, because that's one of the more complex areas for validating admission policy. There is a lot of work that had been done or has been done already to record failures in the status, and we have none of that in DRA at the moment. That issue lists both ideas where enhancements are possible. It's also an area where perhaps some out of tree or separate tool could help people work with cell expressions in DRA. So it's not necessarily a blocker for the next release. It's also something that someone who is interested in this area could do some work on the side to come up with such a tool, for example, and not be pressured to get it done for 132. Try out, look at this issue. It has some ideas. And of course, as you said, there are other areas like simplifying the whole API. That is, I think, not captured in an issue, but it should be, probably because we did discuss it and we haven't really recorded those discussions.
Thank you, Patrick. Abhishek?
Yeah, I know there is no apples to apples mapping for the device plugin side and the DRA API, but at least we should, for simple use cases, we should have a backward compatibility, meaning user should just express the devices as he's doing in the device plugin world, and behind the scenes, these all extra YAMLs get generated.
Yeah, that's kind of this topic here, kind of migration. I mean, right now, you can have both running on different nodes, right? So if we do what you're saying, then we have a problem because well, maybe we don't. I don't know. Like, we have to think, there's a lot to think through there, I guess, is my point.
I see.
But yeah, I agree. Backwards compatibility so that clusters can migrate to the DRA drivers and everything still works would be ideal. That would be awesome.
Mhm.
I mean, at least for GPUs, our plan with the GPU operator is first initial support will be some nodes run the device plugin, some nodes run the DRA plugin. And you have to partition your cluster yourself to decide which ones run which. And then your workloads come in, and if they ask for things using the device plugin way, they get directed to the nodes that are running the device plugin. If you ask for resources the DRA way, they get directed to those other nodes. And then in the medium term, we then want to be able to do like something like what's being described here, either via webhook or some other means, so that people can, we can deploy the DRA driver everywhere. But if someone asks for a resource using NVIDIA.com:2, it will then translate that into the DRA style, auto-generate the proper resources for that, and then allow the DRA driver to allocate them rather than relying on the standard device plugin. But I agree, if we had in-tree support or some automatic way to support that without us having to write our own webhook or whatever for that, that would be even better.
Awesome.
Okay.
Okay. Next item on the list, one of prioritized list of devices. So what are we talking about there? We want to be able to express something in the pod spec or the claim that says, I can accept, one of this device or two of this other kind of device, whatever way we specify devices, you get a prioritized list. And if you can't satisfy the first one, you move to the next one. The use cases is what I just said. I want one, big GPU, or I'll take two smaller GPUs, or four even tinier GPUs, in that order of preference. So that's what that KEP is.
This is the second one on my list of most important. Partitionable devices, then this related to all of the other ones. And the way I usually, like in my head, the way I always frame it is that different selection criteria can be used to satisfy this claim. So either you satisfy it with this selection criteria, or you can satisfy it with this other, or you can satisfy it with this third one, and it is prioritized from top to bottom. You can find a node that satisfies it with the first selection criteria. Great, give me that. If you can't, move on to the next one, and so on.
Right. Exactly. This is pretty high on my list too. Yeah, Abhishek.
Yeah, I mean, you can find a node provided you have nodes lying on there, but there could be scenarios where you have to do preemption, right? So what is our plan to support preemption with DRA?
That sounds like another bullet point. We don't, Patrick or Kevin, we don't have a specific.
What do you mean by preemption exactly?
So, I mean, if you have a fixed size cluster, right, then you have to knock out some workloads to make room for the next workload, right? That knocking off has two criterias. One is if you take the whole node, then you basically maybe fall down to the pod priority, just taking things simpler. But if you go to the partitionable devices mode, then now you have to like cherry pick two partitions that are equal to the next partition that the workload is requesting, right? Or one, two or more, or n partitions that are continuously available on some device such that the next workload can fit in.
I agree that this is something that is worthwhile, and my use case that I had in my head before for this is that, say you have a partitionable GPU, you want to use that GPU for inference when you don't have some more important training job pending. But once there is a training job and you know that you need to get it done, you could define those pods with higher priority and make sure that those other inference jobs get pushed out. I don't have personal experience with how preemption or how this works in the scheduler. That's why I haven't done any work on it or investigations. But it definitely sounds like something that we should investigate.
What I'm failing to understand is how this is related to DRA versus pod preemption in general.
It needs to be implemented by the dynamic resources scheduler plugin. There is another extension hook where the scheduler calls into that scheduler plugin to ask, if I knock out this pod here, will that help solve the problem that you had earlier? That's roughly how it works. That's my understanding of how it works. And
okay, so it needs to be aware of DRA resources in order to make that decision, to know if it will be able to.
The plugin that we have written for DRA needs to support preemption, and it currently doesn't.
Okay, but it's not some completely new mechanism of, oh, we need to understand how to do preemption of DRA resources. It's more hey, the scheduler allows this. We just need to implement the logic so that it can inspect DRA resources in some way to say, if these got removed, now this other pod would be scheduled and it's a higher priority pod. So let me go ahead and schedule this pod to do it.
I mean, but then I feel preemption would vary by the vendor, how the vendor topology is, and maybe we have to write some I don't know if there are interfaces already written for this.
I don't, with the way we're doing partitionable devices, I think it should be fine. Because it will be able to see if these get removed, these other ones become available.
That's where structured parameters help, because with structured parameters, the scheduler knows that if it kills this pod and it makes the assumption that this pod is the only one using a certain claim, which is typically true, then deleting that pod will help schedule some other more important pods. So I think it should be possible to implement this.
Okay.
Okay, awesome. Well, I added that as a separate item. I don't think so I think the layering is okay so that it doesn't actually directly interface with like one of prioritized list, right? Like the layering, that's like lower down. The scheduler would ask, hey, if I remove this, do I get better, can I schedule this other pod? And that's going to work regardless of all these features underneath. If we add prioritized lists, if we add all these different constraints, that's all going to get considered in that question. So I think that the layering is sufficient at this point, that we don't need to worry about interactions, other than what you mentioned earlier, Abhishek, that some of these things might lead to additional fragmentation. But that's kind of like a separate discussion we have to have. Really. Okay. This next one, fractional devices and per device allocatable resources. So the idea here, this is a sort of, it's a little bit like partitionable, but it's more granular. So a device could say, I have 64 gigs of memory, and a claim could say I need 4 gigs of memory, and we allocate that 4 out of the 64, so there's 60 left for other workloads. Now,
this assumes your hardware supports that. Yes.
Well, it assumes you don't need the hardware to support it like as a hard boundary, but you do need the ability to schedule multiple workloads against the hardware easily. And I know that right now, the way as far as I know, there's no hardware vendor that has sort of the right support to make this a useful feature yet, as far as I know. Like, because of limitations like with the sharing, you know, you have the same.
They don't have MPS sharing GPUs.
Yeah, like the same Linux user ID, and like there's other constraints that make it too complicated, I think, to do this. Is what I would call platform mediated sharing. We've talked about in the past. It's like the device is out there, the
versus
platform.
user mediated.
Exactly. There's no user, like we can do different users. There are some technologies like we talked about, Kevin, that somebody put out there that could potentially make some of this work, but all of it's very experimental. So from that point of view, it's a low priority to me. But does anybody have questions? Are you following what it is this does? I mean, there might be other things other than GPUs that find this useful. As far as I know, most hardware devices, even like think about like network, you could theoretically say I'm gonna take a certain amount of bandwidth, right, and have that get a virtual, you know, VLAN tag or something on a physical interface that then gets trained to a certain amount of network I/O. But I don't think anybody supports that sort of thing today easily. So, Varun?
Yeah. Hey, is this use case you're describing, is it different from how you have virtual GPUs on NVIDIA GPU?
Kevin, I would ask. I think he's asking about vGPUs.
Yeah, I'm trying to follow how it. So a vGPU is different because you don't hand out vGPUs, right? The vGPU. Well, let me backtrack for a second. This is different in that we're not trying to just time slice on top of a full GPU with all of its resources. This is saying, you know, with something like partitionable devices, you say, okay, here's a full GPU. I'm going to divide it into these chunks. I'm going to advertise each chunk as a separate allocatable device. And with this, it's saying, no, I've got one device, but it's got a set of resources associated with it. And I want to be able to get access to some subset of that. And so, you know, NVIDIA GPUs don't support this today, but if they did, it would be saying, okay, I've got a full GPU and it's got 80 gigabytes of memory and I want 40 gigabytes of that. And somehow allow the scheduler to schedule a device on this in such a way that only 40 gigabytes of that got handed out for this named device. And there's still 40 available for that same named device to somebody else without having to list 2 separate devices, because that full 80 is completely, you know, it's allocatable in chunks of 1, let's just say, of 1 byte. We probably have some block sizes we have to associate with this, but that's how the idea is different from each other.
I see. Okay.
Does that answer your question?
Yeah, it does. Thank you.
This is basically allowing devices to be treated just like we would a node, right? You can slice it up very dynamically like you can in Kubernetes, but the underlying technology isn't quite there. You could argue that, well, I can slice it up even if it's not enforced, right? Like it's still a cooperative. I can give each of you 4 gigs of memory, and you could ask for 8 and get the 8, but we're assuming that for allocation purposes, but there are other complications, at least with NVIDIA devices, that make it so complicated it's probably not worth it. And then I know it doesn't apply to, say, GPUs really at all at this point. So like, I think that there aren't, and I don't know about other vendors, so I don't know that there's any clear ability to utilize an API like this.
I mean, I think once, if and when the C group interfaces for GPUs ever materialize, then it would become useful. This is exactly what they're trying to allow you to be able to do. It's just they've never gained traction enough to be, to reach maturity in the Linux spec.
Okay. We have only 2 minutes left. I guess just let's get through what we can. Split resource allocation across devices. So this is a combination of that. This is a little bit alternative version of that one of prioritized list, or could be used in combination with it. The idea here is you'd say, you know what, I need 64, or it's just an alternative, I guess. I need 64 gigs of RAM for my workload of GPU RAM. And so I'm willing to take anywhere from 1 to 4 devices to make that happen. So now it's a different way to express how to allocate a set of devices to meet the needs of the workload. And so the scheduler would have flexibility to find 1 device that has 64, or 2 that have 32 each, or 4 that have 16 each, or whatever it may be. Do we see value? That's what it is, I guess. If there's any questions, otherwise I'll move on with our 1 minute left. The next one, compound device DRA driver. Basically, this is built on top of partitionable devices to create a sort of pseudo driver that sits on top of multiple drivers and allows you to allocate pairs or more molecules of devices. So the canonical use case here is, I want to get this NIC and this GPU, and I don't want to serve up the NIC without the GPU. I don't want to make it available to anybody without the GPU. And I want this specific NIC to go with this specific GPU. This enables this to be handled on the device driver side and simplify right now, to do this in 131, the user has to specify these like topological alignment constraints, and they have to know all this stuff. And this is to basically say, you guys don't need to know that. We'll build it into the driver. That's what this is. And we're out of time. We have just a couple left. Please, anybody, we'll move the others to the next meeting, but reach out on Slack if you need anything. And thanks, everybody.
Thanks.